How to use phase diagrams with property tables. Have you ever wondered how to effectively combine phase diagrams with property tables in thermodynamics? Understanding these tools can really simplify your studies. Let's break it down step by step. First, let's clarify what a phase diagram is. A phase diagram visually represents the different states of a pure substance, showing where it exists as a solid, liquid, or vapor at various temperatures and pressures. You will often see regions for single phases and two-phase mixtures, like liquid vapor. Common types include pressure-temperature, temperature-specific volume, and pressure-specific volume diagrams. These diagrams help you identify the phase of a substance based on its conditions. Now, property tables come into play. These tables provide numerical values for thermodynamic properties such as temperature, pressure, specific volume, internal energy, enthalpy, and entropy. They are organized by phase, including compressed liquid, saturated vapor, and superheated vapor. When you know the phase and state of a substance, property tables give you the exact values needed for calculations. To use phase diagrams with property tables, follow these steps. First, identify the state of the substance using the phase diagram. If you have known properties like pressure and temperature, locate the corresponding point on the diagram. This will tell you whether the substance is a compressed liquid, saturated mixture, or superheated vapor. Next, use two independent properties to define the state. According to the state principle, two intensive properties, such as pressure and temperature, uniquely define the thermodynamic state. The phase diagram helps visualize this relationship. Once you have identified the state, refer to the appropriate section of the property tables. If the point lies in a single phase region, use the compressed liquid or superheated vapor tables. If it is in the two-phase dome, use the saturated tables. Here, knowing one property, like temperature, will help you find the other, like pressure. If your substance is a mixture of liquid and vapor, you can calculate properties using quality. Quality represents the mass fraction of vapor in the mixture, ranging from 0 to 1. You can find any extensive property, such as internal energy or enthalpy, by interpolating between the saturated liquid and vapor values. The formula is simple. Property equals 1 minus quality times property of the saturated liquid plus quality times property of the saturated vapor. Sometimes, the exact condition may fall between listed values in the property tables. In such cases, you can interpolate linearly between the closest entries to estimate the property you need. Finally, apply the properties you have gathered to solve thermodynamic problems. With the correct values from the tables, you can analyze energy transfers, work done, efficiency, or other important parameters related to thermodynamic cycles or processes. For example, if you have water at a specific pressure and temperature and want to find its specific enthalpy, start by checking the phase diagram. Determine if the water is a compressed liquid, saturated mixture, or superheated vapor. Then, go to the relevant property table section. If it is in the two-phase region, find the enthalpies for the saturated liquid and vapor at that pressure. Calculate the mixture enthalpy using the quality if it is given. In summary, phase diagrams provide a visual framework for understanding the phase of a substance, while property tables give you the exact numerical data needed for calculations. Using both tools together allows for accurate analysis of thermodynamic systems involving phase changes and different states of matter. This approach makes thermodynamics more accessible and practical for everyone.